Hello everybody, Amol this side from Chirap Technologies, and we are here for a webinar on transformer design software. Welcome to all of you. So dear friends, are you facing any challenges like potential customer demanding a price offer and you are able to comply with their request within 5 minutes? If no, then with this software, you can make it. Is I am audible to you?
आवाज लहान येतो थोडा मोठा.
Yes, Sherry.
Okay. Is I am audible to you, Lakshmikant ji? Now?
Yes.
Okay. So with your potential customer demanding that the price to be reduced with some flexibility on a few of the parameters, can you close with this loop within 5 minutes?
Your voice is not reaching.
Hello. Hello.
Your voice is not reaching us. It is not very clear.
Hello.
आवाज क्लियर येत नाहीये.
Hello.
आवाज येत नाही.
Hello.
हा येतोय आता आवाज. स्लो येतोय खूप.
लक्ष्मीकांत जी तुम्ही स्टार्ट करा नाही तर मग आता येतोय आवाज?
हो येतोय.
Okay. Hello friends. So if maybe wanting to
Please
reduce the
proceed.
overall cost of a raw material by working at the edge of the specification parameter, can you do it effortlessly within 5 minutes? On receiving the order, you are able to submit drawings for customer approval in just 5 minutes. On receiving the order, are you able to provide manufacturing drawings and documentation for production, which is just in 5 minutes? Can you visualize in 3D dimensional drawing how to part and the whole transformer will look like in once built within just 5 minutes?
थोडा आवाज मोठा करा ना. आवाज खूप लहान येतोय.
Can you play around with the existing design to get a new design within just 3 minutes? If you're facing or likely to face
अमोल सर आवाज खूप आवाज येत नाहीये.
Okay, give me a second.
Friends, is my voice reaching you?
Yes, sir.
Okay. So friends, welcome you all for this webinar on automatic transformer designing. Friends, what we are going to say is how automatically the transformer is being designed. Now, some of the challenges that industry faces, friends, let's try to look at the challenges first before we get into the automatic transformer designing. Are you in a position to design the transformers and submit the quotations with all the necessary drawings within 2 to 3 minutes? Are you in a position to revise as existing drawings to work at the edge of the specifications given by the customer within 2 to 3 minutes? Are you in a position to pass on the information related to the transformer manufacturing to the production flow within just 2 to 3 minutes? Friends, if you are facing any of these challenges in your manufacturing setup or the other setups, this is the time to look at the need of transformer design software. Friends, look at this. what we are seeing here is the basic information page of this automatic transformer designing. So let's begin. On the top, you see the design number. You can key in the way you wish to have. You can key in the rating of the transformer you wish to design here. You can key in the. You can go for designing of a distribution transformer, isolation transformer, a power transformer, a converter inverter duty transformer. Let's look at the rating of the transformer. What rating you wish to go for? Let's decide and go for 1500 kVA. Okay, good enough. You can set the primary voltage. You can also go for, there is a checkbox over there that indicates you can go for the dual HV, dual voltage for the HV winding. So 11,000, low voltage, you have chosen it to be 433. You can choose as much as you want. Then you can choose the reference standards. Let us go on the top first. Various reference standards can be chosen, whether it is Indian standard, whether it is IC, whether it is ANSI, CBIP, ECBC, SANS, that's generally followed in South Africa, then European eco designs, or it could be GHOST, that's possible mainly in Russia and nearby, or WABDA, which is prevalent in Pakistan. So let's choose any of the reference standards and go for the efficiency. You have 4 options over there. The conventional, it talks about the highest losses. Level 1 is lower than the conventional. Then you go for level 2. Level 3 is the lowest losses. Okay, when you are on the conventional, let's go to conventional first. Let's go to conventional and see on the left hand side bottom. You are in a position to see the no load loss of 2064 watt and load loss as 16,200. Now, moment you go to level 1, you will be in a position to see the losses reduce. Let's go for level 1. Okay, let's go for level 2. Let's go for level 2 and level 3 and see how the losses reduce. Yes, you can go for level 3. Okay, you can see the losses are reducing continuously. Now the question that comes to possibly any viewer's mind is, if I have to set the losses different than what are shown over here, is that possible? Then the answer is yes. You'll be in a position to set the losses whatever you wish to, but that will be possible as we go from this page to the next page, that is the winding page. Okay, let us select any level as you design now, and then let us go to the vector group. Okay, you may also have a question, what are these levels? As such, there is no significance of these efficiency levels. They are there only to indicate that the conventional is the highest losses and level 3 is the lowest losses, and level 1, level 2 are the lower than the conventional losses. Okay, they are not relevant in terms of any standards, but you will be in a position to set them as you go on the winding card. Okay, you can select the vector group. You can choose anyone. It's 3-phase, 50 Hertz, 60 Hertz, both options are there for the frequencies. You can go for the impedance at normal tap. Whatever you see in the white background is all editable. You can write whatever you wish to write. The tolerance depends upon the standard, reference standard. Moment you go for the different reference standard, the tolerance on impedance possibly will vary. Similarly, the flux density, co-building is stable. You can go for the cooling. Cooling, various options. You can go for ONN, ONF, OFF, ANN, that is dry type in VPI, as well as for cast resin. You can go for the ester oil. The moment you go for the ester oil, you can see natural ester, synthetic ester, both the options are possible over there. Now this 1500 kVA design, whichever cooling you wish to set, you please set, and let's go further. You have chosen it to be ONN with mineral oil. Then you have the tapping. You can go for the tapping, whatever you wish. We're talking about the OCTC. OCTC is nothing but off-circuit tap changer. It is not unlike OLTC. OLTC is on-load tap changer. So let's select anyone and go for the tapping on HV that you have chosen here, -5% to +5%. You can set whatever you wish. You can set the step value. Here you have chosen it to be 2.5. -5 to +5 with the step value of 2.5 will mean there are about 7 taps here. Let's go to conductor material. You have various options in that. You can go for copper as conductor material. You can go for aluminum. You can go for 10% copper, 10% copper clad aluminum, or 15% copper clad aluminum. You can also go for the combination of copper and aluminum, copper being for the HV winding and aluminum being for the LV winding. Okay, one of you is asking the questions. Can we have the different ratings for the different cooling? Yes, let's go for that and see. Let's choose the ONN. Next cooling is ONF. Okay, similarly, go for ONN 1500 and ONF 1950, or you can choose whatever you wish to. Okay, for the sake of demonstration, if you want to change, you can change it and proceed further. Okay, we are on to the conductor material. Let's go for core type. The core type are shown here as D type, S type, elliptical core. There are more core options also possible for some of the ratings. Let's choose some of the other ratings and see whether other options are also possible for the core. Okay, let's see. Okay, for this 500 kVA rating, you are in a position to see here D type flat yoke, S type, D type step lab, the S type step lab, the wound core, shell, wound core, the core type, and then you have amorphous in shell and core, both configurations. You have elliptical core, you have rectangular core. Also, you have EI kind of core construction possible. Choose anyone. If you want to show the different rating as you had chosen earlier, you can go for the same. And let's verify whatever you have chosen earlier is there. Okay, then let us go to the type of tank. Type of tank, you see radiator type with conservator. You can see the sill type without conservator. You can see the corrugated fin with conservator. Sill type without conservator, completely filled with corrugated fins without conservator. You can go for the elliptical tube radiators. You can go for elliptical tube radiator where there is no conservator. All these options have been there as part of. You can also go for, when you go for the dry type, obviously you will have the options further whether you want to go for with tank or bare without tank. Okay, so let's choose anyone what do you wish to. Corrugated fin is the one you have chosen here. The class of insulation can be chosen as ABE. The ambient temperature maximum can be set. The oil temperature rise can be selected from the list given here. Winding temperature rise can be selected or edited here, 50 degrees, 50, whatever you wish to set. The reference temperature can be set here. And the next is you go for the maximum current density. For the LV and HV winding, you can set different current densities for the LV and HV winding. Now, friends, those who have joined in last 5 minutes, I would like to take a recap of what we have done in the last 5 minutes, so that once we go further, it will be difficult to decipher what exactly where from we have started. So let me reiterate where we started. We have keyed in the design number. We chose the maximum rating. That's 1500 kV here. The high voltage winding, the voltage being 11,000. The low voltage winding, the voltage has been written as 433. You can also see the alongside it. Friends, are you able to hear me? Any one of you can respond?
Yes,
Yes,
sir.
we can.
Okay, thank you, friends.
Yes, we know you.
Then you can go for the alongside the ratings. You can see the lighting impulse levels. That is 75 kV is the set for the HP winding. You can go for the 95 kV also. Similarly for the low voltage winding, 3 kV is the alternate current level. You have seen the voltage group. D111 shows a frequency of 50 Hertz. It is for 3-phase impedance at normal tap, tolerance on impedance, core building factor. You have chosen the cooling. Various options are there: dry type, oil cooled, and also ester. You have chosen ONN with mineral oil. And then the tapping, you have chosen it to be OCTC, that is off circuit tap changer, being tapping on the HV side with the range of -5 to +5, with a step value of 2.5%. That makes 7 taps overall. Conductor material copper, and then the core type has been D-type stap lap. You can select other ones also. The type of tanks among the various types that are available, we chose corrugated fin type with conservator. And then the class of insulation A, the ambient temperature maximum is chosen as 50 degrees, the oil temperature rise, winding temperature rise, and the reference temperature, and the maximum current density at which you expect the software to design the transformer. Now, friends, with this, we can go for the next button at the bottom, and this will immediately take you to the winding card of the transformer. Friends, we are on the winding card of the transformer. On the right hand side top, you are in a position to see 1500 kVA, 11 by 0.433 kV. That's the primary and the secondary winding. D11 is the vector group, ONN is the cooling. And then I draw your attention to the table just below that, wherein the first column talks about the parameter, the second column talks about the unit, third column talks about LV winding, then the last 3 columns talk about the HV winding, wherein it has taps, the minimum tap, the rated tap, and the maximum tap. Now let's go through the parameters one by one and understand what they are. Okay, before I could even finish my explaining even the first table, it seems that the design is completely ready. Still, I will explain you the whole table. The area per phase is given for both the winding. The current density per phase is given. The length mean turn is given. The conductor length is there. The bare weight for all the 3 phases in kilograms is given. The insulated weight, the bare weight plus the insulation. That's what the weight you see for the LV as well as the HV winding. The resistance at reference temperature is shown. I square or loss at the reference temperature is visible. AD loss for all the 3 phases is visible. The gradient for all the 3 phases is visible. So I draw your attention to the table. Here you are in a position to see. Here you are in a position to see the reactance in percentage, the design value, the impedance. We have chosen on the basic parameter page the guaranteed value of 6.25. With the tolerance, it comes 5.62 to 6.88, and software designed this particular transformer at impedance of 5.77. This software is such an intelligent one, friends, that it will choose not to work at the extreme levels, but it will give tolerance of 2 to 4%. That is nothing but the manufacturing tolerance based on these designs when you go for the manufacturing of the transformers. Friends, you can see the total I square or loss, the AD loss. What I see in the white background is all editable by the user. Stray loss is also there, which is again editable. The no load loss is given as designed is 1678. The guaranteed value was 1597 with the tolerance as per the IC. it takes maximum of 1757. Now this figure of 1757, friends, is editable because it is in the white background. Let's try to click on this. Okay, and try to edit it. If you can see, if you can change it, 1757, if it can be changed by the user. Let's try to edit this figure. Yeah. Okay, fine. You can escape it if you want, or if you want to put any other value, you can put it. It's okay. Load loss is also designed at 11,638.7 watt. The guaranteed value, as was on the basic page, was 12,000 because it was 10,909 the tolerance as per the IC. Now here also you can see, friends, you are in a position to edit the maximum losses that is to be considered while designing. And the software is such an intelligent one, it will try to go towards the maximum load loss or the no load loss specified and design in that fashion. You can see the no load loss. When the maximum allowable value is 1700, it has designed at 1678. Whereas load loss, when it has been maximum specified as 12,000, it has designed at 11,638. Now I draw your attention to the information below that particular table. You can see the core grade. Now as a default, friends, it has chosen the core grade to be MOH 0.23, but you can change. Yes, you can change the core grade. You have the various options: M6, M5, M4. Am I not visible, friends, to you? Am I audible to you, friends?
Yes, sir, you are audible.
Thank you so much. So, friends, I was talking about the core grade, which is possible to be edited is M6, M5, M4, MOH 0.27, M3, ZH90, then RGHP. You can go for 23 ZDK. And not only that, if you have a core whose core loss is known to you and which is not same as what is indicated over here, it's very easy for you. It is editable because it is in the white background. Instead of 0.93, you can put whatever it is at whatever flux density, that is also editable. You can see the flux density, which can be editable by the user. Let's click on that and see how you can edit it. Flux density, how you're going to edit it. Okay, fine. So it's 1.7. You can go up, wherein you reduce it, you can go down and increase it. So that's very simple. And whatever flux density at which you wish to have the core loss specified, you can do it easily without any hassles. Also, we have seen on the basic parameter page, you had set the current density maximum as 3. On this page, you have the possibility of editing it. You can make it further up or you can go below that. Let's try to show how you can increase or how you can reduce it. Yes. Now, friends, I draw your attention to the extreme right and bottom. You are in a position to see some information related to the core. The core area, 510 centimeters square. Core diameter, the center length, that is the window width. You can see the leg length, that is window height. Now, let me take your attention to the left-hand side column, my left-hand side table. It has 4 columns. The first being the parameter, second being the unit, third being the LV winding, and last column being the HV winding. Friends, as you see here, we are talking about 2 winding transformers. Okay. By moment, our software supports 3 winding, third being the regulating winding, but that is beyond a particular rating. Say, for example, beyond 10 MVA, because this software is possible for automatic transformer designing right from 5 kVA to 80,000 kVA, that is 80 MVA. And the voltage class it supports from the smallest as far as isolation transformers is concerned to the maximum being 138 kilovolts, 138 kV. So let's look at the parameters in the table on the right hand side. You can see the type of winding. For LV, it has chosen layer winding. For HV, it has chosen as a default disc winding. But is there any other option to decide or change this? Let's click on that and see whether you are in a position to change. Yes. For HV, you have layer option. You also have the crossover option. For LV, let us see what are the options it provides. Okay, for layer, you have layer option. You have, for LV, you have layer option. You also have the coil option. Okay, you have the winding direction, then you have the minimum turns, the maximum turns, the normal turns, then the rated phase current, the number of layers and the number of discs are there. Then you can also see below that turns per disc or the layer, the insulation between them, number of ducts, the size of duct, the total number of conductors, the type of conductor, the conductor covering type. You can read here, it is mentioned as double paper covering. You also have the option of triple paper covering. You can also go for super enameled. All these options are there for both LV as well as HV winding. You can also see conductors radially and axially. You can also see the dimensions of the bare conductor. For layer, you can see the width and thickness. You can also see for the HV conductor on the right hand side. Then the paper covering over the conductors. And friends, what do you see here again? What do you see here again in the white background is all editable. Everything is editable. You'll be in a position to see whatever white backgrounds you see, you can change the values the way you want. You can see the radial thickness of winding, the radial clearance between them. That's again in white background. The inside diameter, the outside diameter, the total disc height, that's the electrical height. Then the height of insulation, then the extra packing if you wish to provide, the overall axial length of winding. You can also set the bottom and top clearances, and they are in the white background. That means all of that is editable. So friends, we have seen how the whole winding card gets populated. And one concept which I want to showcase here to you friends is, moment we have made the change in the no load loss, that 1700, that is in the maximum. When we have done that, one change, that effect that took place on the right hand side bottom, the redesign button appeared automatically. Now, once you click on this redesign button, it asks you certain questions. The question is, do you wish to continue with following parameters as fixed? We have changed the grade, we have changed the flux density, we have changed the current density. And with the change parameters, see, currently we have changed and come back to it. But however, if you have changed and remained at that level, this kind of question will propel you to decide that with the change parameters, whether you wish to design the transformer again. Again, another 1 minute it will take, and it will fix these values and make sure the transformer design is completed. Let us see friends, now after this, I'll take you to the core grade. By the side of that, you can see a green button with the white arrow in that. Let me take you over there, and the information that you see is here. You are in a position to see the bus bar size. Again, it is editable, white background. Total losses at normal tap at 50% load, 100% load, highest tap, the lowest tap, zero sequence impedance, impedance at lowest tap, impedance at normal tap, the impedance at highest tap, total turns factor, the face-to-face clearance, again in white background, that means editable, transposition, number of circles, all that. Now, friends, I draw your attention to extreme left-hand side bottom corner. You have there the stack calculations. Moment you click on that, you are in a position to see the stack calculations, wherein the information that you get is core coil assembly weight, the sheet thickness, the number of steps, again white background, that means editable. The step difference is editable. The core weight you can see here. The net area you can see here. The relative flux density at which it has designed with the watt per kg, the loss that is also indicated here in the white background. The no load loss is also is visible. You can also see the number of steps here, 0 to 1 to 9. The moment the number of steps you increase or decrease over that, you can see this particular table getting automatically. Now you have changed from 9 to 11. Now automatically the 11 rows get formed and the dimensions related to various stacks come automatically. You can see if you can read out the parameters like width, the stack mm, the design stack in millimeters, the net area in millimeter square, the limb, side limb, the side limb weight, the middle limb weight, the yoke length, and the yoke weight. The complete information is available. Let me draw your attention to one aspect in this, friends. Now you see for the serial number 1 stack, 260 mm is the width. Serial number 2, it is 245. Suppose you want to change, say for example, 245 to be made to say 250. Let's try to make it. And what the software does, it does the rest of the things automatically. Okay, if you can save this, you can save and go further. If you don't want to make any changes, don't save and click on the next button. Okay, the moment you click on the next button, now is the time for you to go to, before I draw your attention to that, okay, let us first have a look at on the top. Top, you can see design number is there, the basic information page is there, the winding page, which is currently highlighted, that means we are on the winding page. By the side of that, core page is there, insulation page, tank, short circuit, BOM, approval documents. We are going to go through all these things, but let us click on the next button and the software automatically takes you to the core page. Let's click on the next.
So based on the winding information and the stack calculation and what kind of core type we have selected on basic information page, based on that, this core card is generated automatically. Here you will get the information about core type, LV turns, center length, leg length, maximum number of steps, total losses at 50% load, then the relative flux density, then core loss, core filling factor, core diameter, net core length, area, and net weight of the core. Now let's see the printout. There is a table for figure 1, figure 2, and figure 3. Figure 1 is for side blades, figure 2 for center blades, and figure 3 for top and bottom blades. That figures I will show you here. You can see for figure 1, length and width is given in the table. Same for figure 2 and figure 3. And this is the core assembly diagram. Here you can also change the logo, company name, and address. And you may also export this report in PDF, Excel, and Word also. Now I will take you to insulation page. In this page, what insulation we have used in winding page, like core to LV gap, LV to HV gap, and HV to HV gap, means face to face gap. In between this, we use like top and bottom clearances for common block, winding block, permout ring, and the common ring. Same for LV and HV. Thereafter, wedges, cylinder details in between core to LV and LV to HV, then spacer details, then the rings detail, phase barrier detail, transposition, and interlayer insulation detail. This information you will get on this page. Here also, friends, the all cells with white background are editable. You may make your own arrangement of insulation in between the core to LV and LV to HV, taking similar gap. Now let's see the left hand side table. There is information about frame part, like length, width, height, thickness, bolt clearances for the frame. Then frame sizes, core diameter, leg length, center length, blade width, and HVOD. Thereafter, the information about core grade, insulation class, insulation grade, insulation class, material, and total insulation weight. It's 40.91 kg now. And here is the gap between core to LV, LV to HV, and HV to HV. The actual gap and design gap you will get over here. The design gap is taken from winding cut. Now On your left side, left bottom side, there is an arrow for insulation arrangement. You can see here the arrangement of insulation, the electrical height, physical height, where is the core to LV gap, LV to HV gap. In the manufacturing specification, you will get the detailed insulation diagram also with the values. Now I will take you to tank page. On this page, you will get the information about tank, radiator, and conservator. Let's see the tank information first. There are two images. The first image you can consider like a top view of transformer, and A, B, C, D are the clearances from live part to tank enclosure. And these clearances are available in this table, which can be editable. And the second image you can consider as a side view, and E is a top view and F as a bottom view. That value is also available here to edit. And based on that, your transformer tank LBH is calculated over here. The tank length, width, height, including your volume in cubic meter. Now let's say the right hand side table. There is a tank dissipation, radiator dissipation, corrugated quantity. Now we have selected corrugated types. That's why you will get the information about all corrugations and the corrugation tank. If you select another type of radiator, you will get the different kind of information over here based on the tank and radiator type selected on a basic information page. Now we have selected corrugated fins. So let's see the gap between fins, which can be editable, the number of gaps on length side, width side, fin height, fin depth. Here also, the all cells with white background are editable, and that will impact on your total number of fins. Here the fins width, depth is editable, then total number of fins on tank, then limit check functionality, then oil quantity in fins and the fins weight. Thereafter, the conservator information, conservator volume, conservator diameter, length, and oil in conservator you will get over here. If you change the conservator diameter, your length will get changed automatically. Now, let's see the left hand side bottom corner. There is a button for other accessories. For this 1500 kVA, what kind of necessary fitting and accessories are required that we have shown by default? And the option is available in the drop down to select or choose another type of fitting and accessories as per your customer requirement. And that will impact you in bill of material as well as your approval documents, fabrication drawings, everywhere. You can see here the tank side plate thickness, top bottom plate thickness. Based on that, your 3D diagram will generate automatically. Then other drop-down options like OTI, WTI, marshalling box, additional neutral bushings. So these all drop-down options are available to select or choose fitting and accessories as per your customer requirement. Here also the option is available to choose cable boxes, either both side or LV side only. Thereafter, the number of fins on length side. Now, no number of fins on width side are 0 because the sufficient area, the tank length side area is sufficient to occupy heat dissipation. Thereafter, the required pressure sustained by the tank in PSI, that also we have mentioned over here. Now, I will take you to quality card of this transformer. The short circuit details are available over here. Firstly, thermal ability to withstand short circuit forces calculation. The duration, temperature rise for LV and HP is given over here. And based on that, your temperature value, based on the time duration, your temperature value will get changed over here. Thereafter, the no load current calculation. In that, you'll get the magnetizing current, no load current in ampere as well as in percentage. Thereafter, the noise level calculation. Then hotspot temperature calculation, overload calculation, inrush current calculation. And there is a button for loss of life calculation for different kind of overloads and temperature conditions. Now you can see the right hand side table. The table is according to IEC formulas. In that you will get the number of axial conductors, a number of parallel conductors, and the hoop stress information, radial boosting force information, imbalance and balance forces for LV and HV coils, collapsible resistance, bending stress. So this much of information as per IEC formulas you will get over here. Thereafter, let's see the bill of material for this 1500 kVA transformer. This aggregated bill of material as a section wise. First section is a cost summary. In this cost summary, you will get an idea about the winding, core coil assembly, tank and finishing, others and total. How much is the raw material for winding and for transformer. Next is the winding. In winding section, the winding related information you will get over here, like serial number, item code, material, description of item, specification, quantity, unit cost, total cost, or remark. Here also, the unit cost is editable. There are two ways to edit this price. One for this particular design and another for in the database for your upcoming designs. That also I will show you how to change the prices in the database using this add, edit, remove button. You have to click on a edit button to edit or modify this information. Let's consider HV conductor. So 760 is here. If I change here 800, so for your next upcoming design, it will take 800 rupees. Next is the core coil assembly detail. So MS frame part related information, including the sizes of frame part, thereafter the information, lamination information, the core grade and thickness of grade, quantity, and the unit cost and total cost. Thereafter tank and fitting accessories. You will get the tank weight separately, cover weight separately, corrugated fins weight with the sizes, then the oil in tank, conservator and corrugated fins, and the OCTC price is available to edit or manipulate here. Thereafter, the downside, left hand side bottom corner, plus and minus button is available to add more rows or delete some items. This is the way you can add more items also here. Here is the other accessories. What we have selected in a basic information in a tank fitting and accessories page. I will show you where. On this page, other accessories page, that all fitting and accessories taken in the others in the bill of material. And if you want to add more accessories, then plus button is available to add more accessories as per your customer requirement, or you may choose from the drop down list from the page of the core other accessories page. Now let's see the approval documents for the customers. Firstly, datasheet, GTP, guaranteed technical particular. This is the 5 pages of GTP generated based on the basic information page only. And it will give you the all information about the efficiencies, dimensions, weight detail, then the LVHV coil related informations, bushing related informations, then the clearances. And suppose if you don't want this much of all information to send your customer, then the option is available to manipulate this GTP as per your requirement, customer requirement. You can uncheck here whatever parameter you don't want. So that will be skipped in the print and your serial number also regenerate accordingly. So this is the way you can generate GTP in your way as per your practice also. Then this is the way you will get the printout format of GTP. Here the company name, logo and address again editable. Every page has a printing facility and every print you can export like this in PDF, Excel, Word. And this is the GTP of 5 pages. Now closing this. Now let's see the next document, core area calculation. So how we calculated core area, that calculation is given here. Then the flux density calculation. then no load loss calculation, then no load current calculation, then load loss calculation, then fins calculation, or you may say heat dissipation calculation, then thermal ability calculation. In the printout, you will get the report as per like this. You can see the formulas, abbreviations, calculations, and conclusion. As per IEC, the maximum permissible value of temperature attended by the after short circuit is 250 degrees Celsius for copper, and the calculated one is 124.35 for LV and 127.66 for HV. Hence, the requirement of thermal ability is this and satisfied. So this kind of reports you will get to submit to your customers. Thereafter, the hotspot temperature calculation, then the current density calculation, then oil absorption report, symmetrical short circuit current detail. So this is all about the approval documents. Now I will take you to drawings. Firstly, 2D diagrams. So in this diagram, you will get the top view, side view, front view, bill of material, overall dimensions, and the weight detail. And to fill this template, we have one input sheet. Here you can enter the customer related and the project and PO related information. This is the nameplate diagram. So all rating related, transformer related information will get over here, including losses, weight detail, and the voltage and current. Then the terminal marking plate. This terminal marking plate generated based on the what kind of vector group you have selected on basic information page, whether you have selected OCTC or OLTC type of type changer. Based on that, this diagram will generate automatically. Now next, the manufacturing specifications, manufacturing documents for shop floor. Firstly, you can see the LV specification for LV winder. You have to give this printout to your winder only. So all LV coil related information is available. Next is the HV specification. So HV coil related information is available over here, including tapping details, lead number, and tapping terms. You can see the HV coil assembly. This page will also generate based on the what kind of winding type you have selected on a HV side. It could be layer, it could be crossover. Based on that, this winding will change automatically. And the core coil assembly detail. Here you can see the figures for insulation, like core to LV gap, LV to HV gap, then the electrical and physical height, top and bottom clearances, how we arranged with clearances with the insulation. That information is available over here. And this diagram also you can modify using this insulation page. You can make arrangement, insulation arrangement as per your requirement, keeping the same core gap and the LV to HV gap. Next is the internal diagram. Here you will get the HV and LV elevation, side view and top view, and the LV and HV winding detail. Now next is the winding arrangement. This is also generated based on the stack calculation, how much step, blade width, and step we have selected. Based on that, this diagram will generate. And what kind of core construction you have selected on the basic information page, like wound core, circle, or elliptical core. Based on that, this diagram will change automatically. Now we have completed the electrical part. Now let's see the mechanical part of this software. There are drawings for fabrication. First drawing is a frame drawing, then cover drawing, tank drawing, loose part drawing, and thereafter the customer drawings. In that you will get the GA diagram in 2D and 3D. I will show you the frame drawing first. Once you click on a frame drawing, it will open in Inventor software, which is higher version of AutoCAD, and it will give you the drawing for transfer a frame in 2D as well as in 3D. So let's see, the drawings are generating automatically. there is a message to open 2D diagram. You can see, friends, within 20 to 30 seconds, you will get this 3D and 2D diagrams. You need to take print on A3 paper. So the size of paper is given here. And every cutout information, sizes information you will get on this page, on this drawing. 3D view, 2D view. And the most important thing is the weight. The software will give you the exact weight of that particular frame parts. And the total weight is taken in the bill of material. So this is the major advantage. And we also giving this original file to our customers so they can modify this drawing as per their requirement. Suppose if you want to change this whole diameter, then you may easily change using this inventor software only. And the same will reflect in 2D automatically. You can see the frame part, the cutout details. And SS plate is also attached to reduce stray losses. And you can see here any foul or something. So you can easily get an idea about how our frame part will look like. Now I will take you to cover page, cover drawing. On cover, there are some accessories, fitting and accessories like thermometer pocket, air release wash, explosion pipe vent, then the lifting lugs, conservator support, inspection frame with cover, PRV, bushing flanges, WTI city pocket. So all this information related drawings you will get over here. This is the standard diagrams. Now you can see the same way these diagrams are generated for cover. You can see in the 3D, HV side 3 bushings, LV side 3 holes, then the lifting lugs, thermometer pockets, 3 thermometer pockets are provided. The options are available to manipulate this drawing using tank page. You can see the same diagram in 2D with the all dimensions, the top view, front view, and side view, including the bill of material and the exact weight of frame, exact weight of cover. Then the explosion vent, then conservator body. To change this conservator sizes like diameter and length, you have to go to the tank page and there is an option to change conservator diameter. So once you change here, it will reflect in a diagram also 2D as well as in 3D. Now I will show you currently 450 and 650. 450 mm for diameter and length is almost 0.6 meter, 65 meter. That I will show you in the 3D diagram, 2D diagram. You can say the conservator diameter is 450, conservator length is 650. Then conservator body weight, 3D view, side view, left hand side view. You can also see the distance for walls and buckles relay, the cutouts, and some notes. Now let's see the drawing, tank drawing. So for tank also you will get the same dimensions where this tank dimensions, and that also you can modify using this white cells functionality. So it will take 20 to 30 seconds to open 3D diagram as well as 2D diagram. It's depend upon the computer configuration. You can see the fins, tank, lifting lugs, balls, channel, and the same you will get in 2D also. 3D view, top view, front view, and the side view. Now let's check the dimensions. Inside width is 580 and length is 1510. So you can see the 1510 is the length, width is the 580 and height is 1255. That I will show you here. Height is 1255. So you can also modify these diagrams. There is a bill of material, exact tank weight, then the base channel detail, lifting lug detail, then tank curve and 2D diagram for tank curve. So this is all about tank. In the loose part diagram, you will get the cable boxes diagram. Currently, we have not selected cable box, so that's why you will not get cable box, but I will show you how you will get the cable box diagram. You need to select cable box here, then save this, and then you will get the diagrams, a loose part diagram. Now let's see the GA diagram for this. Whatever modification you are doing on this page, tank and fitting accessories, the same you will get in the 3D diagram. So this is the way you can make your 3D diagram as per your requirement. Now let's see the final drawing for this GA diagram for this transformer. So scale to scale diagram you will get in the GA diagram also. If you have any size limitations, then using this tank and fitting accessories page or radiator tank page, you can manipulate this drawing. And the overall dimensions below of material are available with some notes. Now I'll show you the cable box drawings also. So let's save this once you change. On the loose part diagram. So these are the diagrams for cable box. One is for pocket diagram. Another is a cable box diagram for HV side, 11 kV side. And this is the cable box drawing for 3150 ampere rating. You can see if LV side, the bushing type is epoxy type, then this type of cable box will appear. And these are the standard fitting and accessories for tank basically. You can see this cable box drawings also in 3D. Now we've seen one distribution transformer design. Now I wish to show you one power transformer design, like 10 MVA, with the another type of radiator arrangement. So let's see 10 MVA 33 by 11 kV, the dual voltage option also available. Now let's see the reference standard. All reference standards are there. Let's select the IS. Then the oil type, The another options are available to choose cooling type. You can also see the lighting impulse and highest withstand voltage in kVRMS. So based on these impulse levels, your winding arrangement and insulation arrangement will change automatically. Vector groups, we have delta delta options, star star options, star delta option. Then the impedance, normal tap, then the flux density, core building factor, whether transformer has a tap changer, OLTC or OCTC. Once you change the tap changer type, tapping type, the range will decide automatically, and the option is available to modify this range as per your requirement. Now, currently I'm taking OLTC, on-load tap changer minus 15 plus 5, direct 1.25 step value. Conductor material copper, core type S type, step S type. Then the radiator type with conservator, class of insulation, ambient temperature, oil temperature rise, winding temperature rise, and the reference temperature. Losses are decided based on the efficiency level, what we have selected, but option is available to change your desired value. Now I'm clicking on next button. Now you can see on your right side top corner, there is a 10 MVA, 1000 kVA, 33 by 11 kV, DYN 11, and the ONN, oil natural, air natural. Below that, the area per phase, current density, length mean turn, conductor length, bare weight, insulated weight, resistance at 75 degrees Celsius, I square R losses, eddy losses, gradient. Thereafter, in the next table, you can see the parameters like reactance, impedance, total I square R losses, eddy losses, stray losses, no load loss, and the resistance. Here also the by default losses are calculated based on the Westinghouse formula, but you can also use your thumb rule and add percentage wise losses like 10% or 20% as per your previous practice. And based on that, your I square R is calculated. Here also the no load loss is available to edit. Based on that, you can design as per your desired values. Now I will take you to right hand side table. You can see the column wise parameter, second column for unit, third for LV winding detail, and fourth for HV winding detail. Now this power transformer, the both side winding are selected disc winding. And it's depend upon the ampere rating of this transformer, LV and HV side. And based on that, another options in this drop down will appear automatically, the suitable options. Thereafter, the normal turns, LV side, HV side, minimum, maximum, and normal turns. Here also the cells with white background, that all are editable. Using these cells, you may make your existing design also, like existing transformer. Then you can change your interlayer insulations, then the total radial and axial conductors, conductor sizes. Suppose if you have any specific size in your stock, then you can enter that values here. For example, instead of 12.3, you have 15.3. Like 15 and 3, 14 for width and 3 for the thickness, and 0.6 is the conductor paper covering. You can click on redesign button. Once you change that value, redesign button will appear, and there is a message, do you wish to continue with the following parameter as a fixed? So if you want this conductor size fixed, so you can click on OK button. So keeping fixed conductor size, you will get it new design, new optimum design for this. Same for the HV side. You can also change the conductor thickness, radial clearances from core to LV and LV to HV. Then the extra packing option is available. Then top and bottom clearances are available to change. Now let's see the right hand side bottom corner, there is information about core area, core diameter, center length, leg length. And beside that, you can see the core grade. There are options. Once you change core grade, based on that, your no load loss will change automatically. Suppose if you want any particular grade, then you can fix it. You can click on redesign button. The grade option will be there. Same with the flux density. If you have any specific value by customer, you can keep that value as a maximum and design the transformer. If your vendor is core manufacturer is different, so you can edit this core losses according to your vendors. The maximum current density option is available to edit. Thereafter, in this panel, the busbar losses, busbar size, busbar losses, bushing losses for 1500 kVA that already added in the stray losses. And here separately we have given. Thereafter, the losses on 50% load, 100% load, losses on lowest tap, highest tap for 100% load, then the zero sequence impedance, impedance at lowest, normal and highest tap, turns K factor, phase to phase gap, transposition, number of circles. Here the phase to phase gap is available to edit, the transposition and number of circle is available to edit. Thereafter, stack calculation. So with your core diameter, center length and leg length, this core chart is generated automatically. If you want to change the number of steps, keeping the same core diameter, leg length and center length, you will get the design, core design here. You can also choose the specific step difference in between the all steps, then that option also available. If you want to modify steps as per your available material, then that is also possible. So using this software, you can also use your existing material like copper, aluminum, core. Then next is the ratio error button. You can see here, whatever tapping we have selected, like tapping type and the percentage of tapping. Based on that, here the tap positions, number of taps, voltages against that taps, then the voltage ratio, design turns, actual turns, step turns, turns ratio, and the percentage error is available. So for 17 position, the number of taps are 15. So here is the maximum number of turns, primary tap turns, minimum tap turns, required tap winding turns, tap turns, number of steps, the all information is available. If you want to print this information, then print button is available. Checkbox is available to get print in the report. This is the core chart. In the printout, you will get the all diagrams for that. This is the again insulation arrangement. How we arrange the insulation, like top and bottom clearances, core to LV gap, LV to HV gap. That information is available on this page, like wedges, cylinders, then the spacers, then the rings, phase barrier, transposition detail, interlayer insulation detail. Whatever values are zeros that are not applicable for this design, and it will be automatically removed in the reports. So using this functionality, using this white cell functionality, you can make your own insulation arrangement also. Now next is the tank page. Now here you can see the tank information, radiator information, conservator information. Now the radiator type are different than the 1500 kVA. Here these diagrams are same for top view and side view, and the clearances are available to edit in the table. And based on this, you will get the tank total length, width and height. The same we have shown in downside, including the volume in cubic meter. Now let's see the right hand side part. There is a tank dissipation, radiator width. Multiple standard options are available here, like from 226 mm to 520 24 fluids. And based on that, your number of fins will get changed accordingly what kind of width you have selected. So if you have any limitations for dimensions, so you can rearrange using this functionality and you can fix the dimensions as per your requirement. Thereafter, the center distance, then the number of radiators. This value also available to edit, and based on that, your total number of fins per radiator will get changed automatically. Then the conservator information. Now currently the conservator diameter is 600, but if you want 540 or 650, then based on that your conservator length will get changed automatically. Now let's see the other accessories. So for this 10 MVA, you can see the all required accessories are available, like OLTC model, OTI, WTI, which kind of OTI, WTI required, that all automatically decided by software. But still, if you want to choose anything from the drop down as per your customer requirement, then you can select from here. Then it will impact on the bill of material as well as a manufacturing drawing. You can see the cable box option as well as option bare bushing option on side. So the all options are available. Using these options, you can manipulate or you can generate your diagrams 3D as well as in 2D. Now let's see the short circuit details. Here also the thermal ability withstand short circuit forces, then no load current calculation, noise level calculation, hotspot temperature calculation, overload calculation, inrush current calculation. Here the loss of life calculation and the table of the calculations as per IEC, short circuit calculations as per IEC. Thereafter the bill of material for this 10 MVA. You can see the cost summary, binding related information. Now here the tapping conductor, then the core assembly detail. So MS part and laminations are available here. Then tank and finishing detail. You can see now tank weight, then the cover weight and sizes, radiator sizes, then the oil in tank, radiator, conservator, and the OLTC. OLTC also has oil and that quantity is shown oil. Thereafter for 10 MV, you can see the automatically fitting and accessories are selected. This much of fitting and accessories. So if you want to add more accessories, then downside plus button is available to remove or add some more rows. And to change prices or to change this data like unit cost or vendor, you have this functionality we have given. You can also export this bill of material in the Excel using this functionality, and you can add your margin or other wages here or net profit in your format. Then the approval documents. So 5 pages of GTP generated for this 10 MB also. And again, the option is available to remove some item from this GTP. And based on that, your serial number also will get rearranged. You can see the 10 MVA copper 33/11, all information. Customer logo and company name is available to edit. Core area calculation, flux density calculation, thereafter the no load loss calculation, no load current calculation, load loss calculation, fins calculation, thermal ability calculation, hotspot temperature. These all calculations are available for all type of transformers. Now let's see the diagrams. This is the general arrangement diagram, and the fitting and accessories are given separately. Now let's see the rating plate. Split of made in India. What kind of currency you have selected at a time of installation? Based on that, this name will change automatically. Now you can see we have selected OLTC and the tapping range and this terminal marking plate is generated accordingly. The number of switch positions are 17. The connections are given. Against that connection, the voltages, no load voltages, and the LV voltages against that. Then we use the CT for W phase. If you want to use that CT in neutral phase, then that option also available in the fitting and accessories page. And these diagrams are generated based on tapping and the vector group selection. Now, let's see the manufacturing specification for shop floor. Then this is the LV winding detail, HV winding detail. You can see the tappings for OLTC, the lead number and tap turns. Then the HP coil assembly. You can see the insulation arrangement in between the discs. There is a 3 mm insulation, but between the tappings, the insulation will change automatically. Now you can see here the insulation diagram, total height and the electrical height, physical height, in the gap between core to LV, LV to HV, top and bottom clearances, how we have arranged with the permount ring, top common ring, top common block. You can also change this value as per your requirement using insulation page. This is the internal diagram for OLTC. Now you can see the leads for OLTC are outside. Here you can see the size of as compared to 1500 kVA. This is automatically changed. And this number of steps you will get exactly what you have selected or what software has in step stack calculation. Now next are the 3D diagram for the same. Let's open the frame diagram. And this 3D diagram you can also export to AutoCAD, and there also you can do changes if you wish, or if you are familiar with the AutoCAD. So see, drawings are generating the message for 2D diagram. Now this is the frame for 10 MVA drawing. You can see the support plate is given provided, and for OLTC leads there are the cutouts. Then HV frame, then LV bottom frame, then base plate, and this is the drawing in 2D, including the weight details and each and every cutout. Thereafter, the tie rod drawing is available here. Now let's see the other diagrams. Cover drawing. So cover accessories, you will get automatically the standard file generated for this. Now this is the cover drawing for 10 MVA. The bushings on top, then the lifting lug, pipe for buckles relay. Then next is the cover diagram. You can see the top view, then the front view, 3D view, bill of material, the exact weight, notes, then the explosion vent. So this kind of explosion vent is automatically generated based on the kVA rating and the tank type. This is your conservator. You can see the arrangement for silica gel breather, then the buckles relay and wall, and the clamping arrangement on the tank. And the same you will get in 2D also with the all dimensions. And this diagram you can also export to AutoCAD, normal AutoCAD. Then next is the tank drawing. So you can see how fast the drawings are generating. Within 30-40 seconds, you'll get the all drawings. It's opening very smoothly. So this is the tank drawing. And you can see the radiator arrangement, OLTC arrangement, inspection cover for OLTC, then the jacking pad arrangement, then the stiffeners detail. Then let's say the 2D view for this. Inside length, inside length, then the tank curve detail, then the inside height detail, radiator to radiator distance, center to center distance, then the cutout details, jacking pad details, exact weight, and the bill of material for this. So we have some standard diagrams also for this bill of material. Then the tank curve and tank curve in 2D. Now let's see this diagram, GA diagram in 3D now. So the drawing is opening. This software is suitable up to 80 MVA. You can make sizes, the resolution, you can change the resolution as per your paper size. And here also you will get the overall width, length, and the dimensions with the bill of material. And you can see this. If you want to increase number of radiators, then the option is available to on tank page to provide pipes and make maximum number of radiators if you have any limitations for width. But software is taking care of the CZ balance. It's simulating automatically. So this is all about the power transformer. Now I wish to show you user manual for this software. So you can see the index covered about 28 points. After the DTPT reference standard, what kind of reference standard software has we have developed in the software with the full forms that all given. Then the efficiency level. As per IS 1180, there are losses, 50% and 100% losses that is also available in the software. And what is meant by level 1, level 2, level 3, and the conventional, that clarification is given. Same for the cooling types. The full form of coolings we have given here. Then the suitable winding types. For LV and HV, we have 7 type of winding combinations as per the current. And that winding type we have explained here. Then the interlayer winding, disc winding, then the material suitability for dry type and oil type, then core building factor, then the material densities for weight calculation, then conductor covering types. There are all type of conductor coverings like super enamel, then the for dry type you'll get a DFGC. Then the insulation grade, CRGO insulation grade, then the stacking factors for different kind of cores, core densities, for weight calculation. You can see the core chart, watt per kg chart with the grades. Then the losses chart as per 1180 IS with the impedance and kVA rating and the losses. Now you can see the core type. Software has a multiple options like D-type flat yoke. So what are the difference? The differences you'll get in these diagrams in the PDF, like wound core, shell core, amorphous core. Then the insulation classes. For dry type, it will take automatically F and H type. Then the insulation materials for dry type and all type transformers. Then some winding parameter explanations. Then the core coil assembly details for different kind of core construction, like circular or elliptical construction. Thereafter, the coil pressing procedure, like how much pressure you have to give individual LV and HV coil and the combined, and how much is the ovening time for a temperature, and how much it will be the temperature. That information is given here. And after ovening again, how much pressure you have to give for individual and combined with the hydraulic jet. That options are given here, the information. Then the interlayer insulation formulas, then the conversion of mil to mm, then the winding, where to use mill paper and duct and the blocks. Then the clearances, minimum and maximum limits for core to LV, LV to HV, and the HV to HV that we have maintained here. Then the end clearances against the voltage levels. Then the some definitions and like current density, impedance. In impedance, we have taken plus minus 2% manufacturing tolerance also. Then the frequency variation, then the unit rate changing procedure. There are two ways. One is the temporary and permanent. Then the silica gel breather, where to use, how much kg, that information is available here. Then the Buckos relay detail for GR 1, 2, 3 and the kVA limits for that. Then the tapping ranges, these are the some standard tapping ranges with the number of steps, number of position and the number of leads. But software has option to edit any kind of tapping, any value. Then the lifting lug weight bearing capacity formulas. And there are some standard fitting and accessories. And there are some frequently asked questions by customers. Now, if you have any question, then you can unmute yourself and ask here. So we are happy to answer you. Otherwise, you can use chat box for the same to write your question. I will answer you from the chat box. I also wanted to show you here the option for design storage, design search panel. There is a panel with the, you can save here a number of designs and the search option is available. You can see the winding, core, insulation and the last save date and the last updated modified date. You can also change the user IDs. Database backup option is available to take, then the report heading and the radiator images. So this is the way you can take your database also, and your database is secured up to you only. Now I'm opening the same design. Let's double click over here. If you want print, then print button is available in the option. You can open any kind of design from here. So if you have any question, you can unmute yourself and ask here. Parallelly, I'm checking the checkbox, chat box. If any question is there.
Friends, you may be wanting to know how this software is to be purchased. This is available, as has been told to you. It is in two varieties. One is the basic version wherein you get the electrical design and documentation, and the advanced version which gives you basic, that is electrical design and documentation plus inventor based 2D, 3D drawings. And this software is available in the license form for 1 year, 2 year, 3 year licenses. And also it depends upon what's the maximum rating up to which you would like to design the transformers to this software. As has been informed earlier, you can design right from 5 kVA, you can go up to 80,000 kVA, that is 80 MVA. And the pricing will depend accordingly. If you have any questions, please feel free. We'll be more than happy to answer them.
Hello, everyone. Hello.
Yeah, Mr. Lewu, please go ahead.
Yes, I've got, okay, maybe few questions, but some of them I think you've already covered. No? I wanted to check, okay, with this software, can we do special type transformers? Like the furnace transformers, the converter transformers, stuff like that. That's one of my questions. I'm not sure if I should ask all the questions or I should ask one after another.
Yeah, currently that option is not available, but we are working on it and it will be available very soon.
Okay. And then I saw also when you were specifying the type of paper insulation for the windings, I didn't see any Nomex paper. We normally call it Nomex paper. Any option for that in the near future? Or
Yes,
it was there, I didn't
that
see
option is
it?
already available. Super enameled in dry type.
Or it's available?
Yes.
Okay. And then, okay, maybe this I didn't see because normally you were using a small transformers for as an example. How do we choose for both the winding and the core if we have cooling ducts? How do we see it on the software? How do we tell that there is a cooling duct or for the core or for the windings?
Yes, the option is available to choose number of cooling ducts and the size of cooling ducts. Even if you are using the rectangular core, the width side, how much number of ducts and the sizes you want, and the width thickness side, how much you want number of thickness. So that option is available to edit.
Okay, maybe another thing, since you have answered like that, on the next seminar, is it possible for you guys to prepare a bigger transformer? Since you said the maximum is an 80 MVA, can you prepare us about an 80 MVA transformer? So that we can, because that's the one that will give us more options of the questions that I was having actually, or that I'm having. Because on one of the options, the question was up to what voltage is this software capable to handle? Is it 132, above 132, 400, 765, up to what voltage?
Yes, but currently we have up to 132 kV and in 2 BIL, 550 and 650 BIL, up to 80 MVA. Even that you can use there the CTC conductor, bunch conductor, rectangular conductor, and the ducts option for core also and the core coil also. So that available about 10 MVA and up to 80 MVA currently. And 132 kV, sorry, 136 kV is the maximum voltage level, voltage class. Currently we
Okay.
have with the software. But in future, we have planned to develop to go higher side of voltages as well as the kVA rating.
Like, sorry to ask a lot because I was writing a lot of things while you were going through. One of the, maybe let me try to ask three, and then the last one probably it will be on its own. Okay, generally, can we do interleave windings on this software? And then let's see what the system. Okay, can we do interleave windings, especially like interleave disk on this one? And then the second one, let me just go through the three of them, and then I think that will be the last one. And then the second one is, I see on your 3D drawings, you are using Inventory as a program for those ones. Can I, on the same program that we have, can I use, if I'm using SolidWorks, can it also work? Or I need to get Inventory for it to be compatible?
Yeah, you need to get Autodesk inverter for the same, because we made a lot of people are using AutoCAD and they purchased the higher version of Autodesk Inventor. For that, we made these diagrams in Autodesk Inventor.
See, once these files are available in Inventor, maybe you can use these files as it is in SolidWorks. If they open in SolidWorks.
Any other questions, sir?
Somebody had asked the bill of material that comes, what's the basis for that? It is basically, whatever population of the parameters as happens on the winding card. And as you have seen very clearly, whatever losses that you specify, whether it is a no load loss or a load loss, it tries to optimize for the losses. Thereby, your cost of investment is the lowest. And that is the basis for populating the bill of material. Ultimate objective of use of this software is to reduce the cost, become very flexible in terms of giving customer the value what he wishes in terms of the pricing, in terms of the costing, and in terms of maneuvering the manufacturability of the transformer and passing on the information or immediately.
There is a question from Mr. Kohan. What about the double or triple voltage transformer design? So currently we have only isolation transformer option is available to split kVA rating and voltages into 2, 4, and 6 sections. You can also say the solar transformers kind of transformer you can design using this software. There is one more question. What is the level 1, level 2, level 3 losses? Currently, as per IS 1180, up to 2.5 MVA, Indian standard has some losses, and that losses are available in the software. Same losses, like the same functionality is available with the SAN standard also. The SAN standard has some losses, and if you select the SAN standard, you will get the SAN's losses. And if any standard don't have these values, then we have given some standard values, but the option is available to edit that values. There is one more question. The software is paid. Yes, the software is paid. Does the software is pulling rating?
Gokan also has asked the questions related to T2 losses, because the company has been exporting 50% of their production to the European Union. So T2 losses will be definitely possible for you to keep it and then design. That flexibility, as I have explained you very clearly, either you can select it from the basic parameter page, or when you go to the winding page, you'll be in a position to set no load losses, the Eddy losses, the stay losses, as in T2 for the Europe. Some friend is asking whether the trial version of this software is available. Friends, you can, if you are interested and keen on having this particular software, you can also request for one-to-one demonstration of this particular software, as we have done the webinar today here. There is no free version available.
Okay, sorry guys, just one last two questions from my side. I just want, what are the system requirements for this software on the computer or on the laptop? And the last one is, I'll direct it to Amol, because, or even you, Rajush, just to send me a full quotation, a code full for this program if I want it. And also like the breakdown, a full quotation, and then we'll take it from there on the WhatsApp platform.
Okay.
Thanks.
Okay, Mr. Levy, we'll communicate to you individually.
And this is our customer list.
Yeah.
So more than 105 customers currently we have from the global, and the highlighted are from UAE, Ghana, Bangladesh, UK, Zambia, Saudi Arabia, Turkey, Bangladesh, Russia, Syria, then the South Africa, Brazil, Bhutan, Pakistan, Nepal, Kosovo, Ukraine, Israel, South Africa, South America, Ethiopia, Malaysia, Oman, South Africa, Turkey, Canada, Pakistan, and a lot of customers from India, the reputed manufacturers. And they also given some testimonials report for us, some performance certificates. This is the BNC Energy. They are using up to 10 MVA transformer. Thereafter, RPPL. They are also using our transformer since February 2020. They also tested this transformer in the test laboratory, like Eddy or CPR, and they got this result. You can see the guaranteed parameter, designed parameter, and tested parameters. Thereafter, triple E power solutions. They are using up to 10 MVA. Thereafter, BNC Energy Infra. They are also customers from last 2019, and they are satisfied with this. Then Digvijay Industry. Then again, triple E power solution. GTB transformer, they are using since last 2018. Homec transformer from Sikkim. They are using our software from December 2016. Thereafter, the Marsan Energy, they purchased in 2018, and the certificate is given 2020 after 2 years, and they are satisfied. You can see PM Power. They are using our 2D and 3D software since December 2019. Then RPPL, they are using 2D and 3D software now. They are given certificate. Then Schneider transformer from Ghana. Then the Static Electrical from Pune, they are also using our 2D and 3D software up to 10 MVA. Thereafter, Tanelec Zambia. They are using since August 2017. Thereafter, VV transformer. They also tested some transformers from CPRI Bangalore. This is the testing lab. And they tested 250 and 400 kVA. And all tests are successfully passed. They are written here. So this is all about the certificates we received from our valuable customers. So if you have still any doubt, please ask. You can unmute yourself and ask here, or you can use the chat box.
There's a question from Mr. Pradeep. Pradeep, is any support available for defining sizes of transformer foundation? See, for EI core, the sizing of the core is possible to be decided. In case of other transformers, you may achieve with some the editing facility that is provided on the winding card. Mr. Pardeep, you can arrange this demonstration for your management as you wish. And we can showcase the same thing for your requirements to your management, and then they can take a call on this.
सर गोखा यांच्या एकदा क्वेश्चनच्या आन्सर आहे तर पुन्हा एकदा सांगा, पुन्हा मध्ये ऐकू आलेलं.
Yeah, Mr. Gokhan, what I had said was your objective is to go for the T2 Europe losses, and those will be possible for you to set in the software. You can do that when on the winding card. You can set whatever losses. You can edit no load losses, maximum, the maximum load losses. You can edit the Eddy losses. You can edit the stray losses, and accordingly, the transformer design will happen. I hope I'm audible to you and it's clear to you now. Then the software also provides you the efficiency calculations.
Yeah, software will give you the efficiency and regulation calculation based on the losses. So whatever maximum efficiency you have, you can check in the GTP, and there also you can set the losses and check with the efficiency on the 100% load, 75% load, 50% load, and 25% load, even on a lagging and 0.8 leading
Power factor.
power factor. Yeah.
So this guaranteed technical parameters is a 5-page report, and your choice to reduce the contents to be handed over to the customer while taking the print or taking the PDF file out of this. So this facility of providing the calculations is already there, and it was already demonstrated the n number of tabs that are there related to various calculations for almost all the major parameters. Efficiency calculation need not be done by hand. It is already part of the program and it comes immediately and automatically. Friends, as I mentioned earlier, the pricing of the software depends upon the three factors. Number one being whether you want a basic package. Basic means electrical and documentation. Advanced means basic plus based 2D, 3D drawings. That is number one. Number two, it depends upon what is the maximum rating. Currently, it supports right from 5 kVA up to 80,000 kVA. The maximum voltage class being 38 kV. Third factor depends upon is whether you need the license for 1 year, 2 years, or 3 years. So once this is known, you will be in a position to receive the price for the software. So friends, if you don't have any further questions, this is the time to thank you for being with us. And thank you for investing your 2 hours with us and understanding how automatic transformer designing happens and the world's best transformer design software that's available for you to help your customers, to help your company, and add value to the operations wherein transformers are designed, manufactured, and tested on your floors. Thank you, friends. Thank you for being with us. And at this time, I wish to thank Mr. Osman, Tinley, Burak, Praveen Kumar, Dr. Muhammad, Johan, Fazrin, Senthil, Amjad, Liu,
Thank you.
Mr. Mohan. We thank Muhammad Sheikh. We thank Shubham, Raja, Subhash Kumar, and many of the friends.
Thanks, sir.
Thank you so much. Thanks for being with us.